They are born atop endless oceans. Clouds and rain, winds and pressure. They gather their strengths exponentially and expel them explosively. They roar ashore and can change forever that which lays in their paths. They are hurricanes, and in destructive force, they have no equal on Earth. These historic scenes, shot by Thomas Edison, show the devastation following the hurricane that struck Galveston, Texas in 1900. In the wake of the storm, which had no name, the small town, which had no warning, lay in near complete ruin. Over 12,000 people lost their lives. In the nearly 100 years since, hurricanes have gained names, and people in their paths have gained the overwhelming survival edge of highly sophisticated storm tracking and warning systems. Thanks to these advanced warning systems and to the evacuation procedures they permit, death tolls from hurricanes and typhoons have been dramatically reduced. With today's storm tracking and path prediction systems come time for warning, evacuation, and survival. Yet, with no real significant change in the way we build, survivors will continue to return home to scenes of destruction, little different from those of Galveston nearly 100 years ago. But there is change. There is an alternative to destruction. There is now an accepted, proven building system that in tests only Mother Nature could conduct is emerging virtually unscathed from a hurricane's fury and destruction. There is EVG-3D, the strength of innovative construction technology to match the force of hurricanes and typhoons. For those whose location places them at risk from a hurricane, over 70 million people along the coastlines of the United States, and the millions living on the islands of the Caribbean and in Central America. The EVG-3D panel system has ceased to become merely an option in building to survive a hurricane's force. EVG-3D has proven itself to be the answer to a question over a century in the asking. The remarkable hurricane resistance of EVG-3D structures was dramatically established in South Florida in 1992, following the stunning level of destruction from Hurricane Andrew. It was here, in the small town of Homestead, Florida, where Andrew's horrific destruction was nearly total, that a small handful of low-income houses, all built with the EVG-3D system, emerged virtually damage-free. In the storm's aftermath, these homes and the 3D system immediately gained national attention in both the media and in the construction industry. In fact, shortly after Hurricane Andrew, the EVG-3D system gained approval from the Metro-Dade County Building Code, arguably one of the most stringent and hurricane-relevant set of building codes in the country. The 3D system, already in use in homes, commercial structures, housing developments, and even prisons around the world, primarily for its strength, construction speed, and energy conservation advantages, is now being specified for structures where hurricane and typhoon tolerance is of utmost concern. The strength of EVG-3D versus the force of a hurricane. There is perhaps no better proving grounds than the islands of the Caribbean. And in the sheer number of named storms, there has been no year like the hurricane season of 1995. the most active hurricane season in over 60 years. A total of 11 hurricanes and 8 tropical storms did $7.7 billion in damage while killing 121 persons. Many of these roared out of the Atlantic into the warm waters of the Caribbean and across the small islands that are home to millions of residents and a magnet to millions more visitors. Here in the Caribbean, as in Florida, the survival story of the hundreds of structures built with the Insteel 3D system is a truly remarkable one. During the first days of September 1995, Hurricane Lewis, a Class 4 storm with sustained winds of over 140 miles per hour, arrived to begin a month of devastation and misery for the Caribbean islands. Hurricane Lewis ripped across the islands of Antigua, St. Martin, and St. Kitts, destroying buildings, leaving thousands homeless. On the island of Antigua, Jolly Harbor, a 160-unit condominium development built in 1991 entirely with the Insteel 3D system, withstood the storm's fury and emerged undamaged. Kevin Belizaire, a structural engineer and building contractor on the island, examined the units at Jolly Harbor following the storm and was startled at the absence of damage.
I'm amazed because I looked up at the roof line, which is where most of your traditional type roofing allowed water through. There were no signs of it at all. The ceilings were perfect. I'm impressed.
The success of the Insteel 3D system at Jolly Harbor would be the first of many such stories as the storms of September continued for the Caribbean. September 15, 1995 will be long remembered on St. Thomas, largest of the U.S. Virgin Islands. On that Friday, a scant 2 weeks after Hurricane Lewis, Hurricane Marilyn, a Class 4 storm packing winds of 115 miles per hour, slammed ashore. These scenes, taken just 2 weeks after the storm, document the estimated $3 billion in destruction suffered by the island. Thousands of homes and buildings made from the conventional building materials, wood frame, concrete block, even metal frame, that are so prevalent throughout the islands, stood no chance against the massive storm's winds. Tens of thousands of people left homeless. Fleets of boats destroyed. And countless blue temporary shelter tarps, the sign of destruction everywhere. Yet on this island, decimated by the back-to-back hurricane winds of Lewis, Marilyn, and by the over 100 tornadoes the storm spawned, homes constructed with the Insteel 3D system survived unscathed. One such group of homes were developed by island builder Peter Clark. These homes, situated on a hillside and surrounded by so many others that were destroyed, were built entirely from the buried water cisterns to the roofs with the Insteel 3D system.
90%, 95% of the homes were damaged, 50% totally destroyed, and we really came through without a scratch. A couple broken windows possibly, but not even a stress crack in our concrete.
The home of island residents Steve Morton and Mattie Jones, also built with the Insteel 3D system, withstood Hurricane Marilyn with no structural damage.
I'm real happy with the Insteel forms for sure. I mean, we did not see any moisture at all come through the concrete. There was absolutely no movement of concrete walls, which after the fact amazed me because there's no interior wall.
We feel very secure in the house going through a hurricane, this last hurricane with winds sustained at 200 miles an hour. Our house is standing, we have a roof, we feel very lucky, it's wonderful.
Of special note is the fact that the home's conventional wood roof, installed in tandem with the Insteel system walls, remained completely intact. This home as well, under construction with the Insteel 3D system at the time the hurricane struck, escaped the damage that laid waste to so much around it. How do walls, roofs, and other structures built of Insteel 3D withstand a hurricane's force, while wooden frame, concrete block, and metal frame structures are destroyed or severely damaged? Construction with Insteel 3D panels produces a building system of uncommon design flexibility, remarkable ease of installation, superior cost efficiency, and astonishing strength. Its components are simple. The Insteel 3D panel system consists of a three-dimensional, welded wire space frame integrated with a modified expanded polystyrene core. The 3D building panels receive their superior strength and rigidity from diagonal cross wires, which penetrate the polystyrene core at acute angles, and which are welded to the wire mesh fabric on each side of the core. This patented process creates a unique truss pattern that is exceptionally rigid and provides adequate shear transfer for nearly full composite behavior. The lightweight 3D panels, manufactured using a patented process that produces panels 4 feet wide by any required length, are easily placed in position, connected to one another, and covered with concrete on both sides. The light weight of a 3D panel, a 4 by 8 foot panel weighs just 38 pounds, delivers distinct advantages in shipping weight, job site handling, and installation speed. The panels are quickly installed by being placed over slab-embedded rebar or steel dowels, then interconnected to each other by pneumatic fastening tools or wire ties. Window and door openings are easily made, and all electrical and plumbing conduit quickly routed between the wire mesh and the core. Shotcreting both the interior and exterior surfaces of the panels produces a monolithic building shell possessing unsurpassed strength as well as outstanding insulation properties. The Insteel 3D panel system is not a new limited application system. Insteel 3D has literally been the worldwide focal point of a revolution in the construction industry. In upscale homes, low-income and multi-unit housing, office buildings, apartment and condominium projects, nursing homes, sound barrier walls, correctional facilities, schools, and countless other construction applications, 3D performs. Hurricane Marilyn was no kinder to nearby St. Croix. Amid the littered remains of conventionally built structures, homes on St. Croix constructed with Insteel 3D panels, like this one overlooking the ocean, sustained absolutely no structural damage of any kind. Nor did this new 1,200 square foot home, which was under construction using the Insteel 3D system at the time the storm struck. And on nearby St. John's, an elementary school built of Insteel 3D, the only such structure on the island, withstood the destruction of Marilyn and served as a storm shelter for many who were forced to evacuate their homes. This performance by Insteel 3D comes as no surprise to Insteel Construction Systems, manufacturer of the panel system. In exhaustive and controlled testing procedures, wind load tests, shear tests, compression and flexural testing, and extensive computer modeling simulating the most extreme conditions, 3D panels excelled as no other building system has before. Yet Mother Nature continues to deliver the sternest of tests for this building system that seeks to change 100 years of construction thinking. This structure, a University of California scientific research complex located in the Mojave Desert, withstood the 1992 Landers earthquake, measuring 6.9 on the Richter scale, the strongest in the U.S. in 40 years, with absolutely no structural damage to its 24-foot-high walls, roofs, or large glass areas. The catastrophic hurricanes of recent years have emphatically proven the remarkable strengths of the Insteel 3D system, and in the process, opened the eyes of architects, structural engineers, developers, and the construction industry as never before. The devastation from hurricanes continues to be a grim reality for much of the United States coastline, Central America, and the islands of the Caribbean. But the demand for construction methods that can withstand these storms is now intensifying. InSteel 3D structures have proven their strengths in storms in Florida and the Caribbean. Municipal bodies such as Metro-Dade County, along with CABO, the Association of SBCCI, ICBO and BOCA, and HUD in the United States, ARPE in Puerto Rico, and similar governmental bodies in Mexico have granted building code approval to the InSteel system. And in ever-increasing numbers, architects and engineers with projects in storm-prone areas are viewing the InSteel system not as an alternative, but as an imperative. And in the Caribbean, where the impact of hurricanes is now so tragically evident, InSteel's impact on fundamental changes in the rebuilding process is equally dramatic. In the Caribbean, InSteel representatives are now overwhelmed with inquiries from homeowners, architects, builders, large-scale developers, and insurance companies who now see InSteel as the proven solution. They, like so many others before them, are no longer comparing building methods merely on the short-term benefits of comparative prices, but rather on the long-term advantages of reduced life cycle costs, strength, durability, and structural performance. With a renewed sense of urgency born of widespread destruction, the collective benefits of the InSteel 3D system are being embraced. Design flexibility, ease of installation and handling, speed of construction, energy conservation, and proven storm tolerance. Hurricanes are a reality. For countless years, they have brought winds of destruction. But now, as the performance record of the InSteel 3D system has so clearly emerged, these storms are also bringing about winds of change to the construction industry. Right now, somewhere on an ocean, a storm is gathering strength. People and homes lie in harm's way. And somewhere along the dunes of the American coastline, in seaside cities and towns, and on the hillsides of a Caribbean island, InSteel is rising to the challenge. If you would like to know more about the InSteel 3D system, including test results, engineering and structural data, specifying guides, and installation examples, please call 912-264-3772.